We're going to be going over Module 4, Lesson 31, Exercises. This exercise is located in your Eureka Math book, Module 4. Let's get started on reading. Sarah is purchasing pencils to share. Each package has 12 pencils. The equation n equals 12 times p, where n is the total number of pencils and p is the number of packages, can be used to determine the total number of pencils Sarah purchased. Determine which variable is dependent and which is independent. Then make a table showing the number of pencils purchased for 3 to 7 packages. Pause the video now, look in your book, and reread the exercise number 1 that I just read. I want to make sure that you read that 2 times before you press unpause. If you don't have your book, you can simply rewind the video until it gets to exercise 1 and you can read from there. Remember to highlight, circle, underline, or square important information that you will need to solve the problem. Now that you've taken some time to read, highlight, square, circle, or underline what we're going to do, we are going to look at the table and try to complete the table. So right over here, I just wrote down some information that I pulled from what I read. I put n equals 12p, and I got that from here. It's circled, so we know that the equation that we're going to use is n equals 12p. And then I wrote also that n is equal to the total number of pencils. I got that from over here. N is the total number of pencils, and p is the number of packages. So p equals the number of packages. Okay? One package is going to have 12 pencils. We want to make sure we write that down, 12 pencils. So first we need to determine which variable is dependent and which is independent. If we look to the equation n equals 12p, we know that n is going to be the dependent variable because it is a result, it is equal to what happens when you have 12 times whatever p ends up being. In the left column, we are going to write p, packages, is the independent variable. In the right column, we are going to make sure that we have n, which is equal to the number of pencils, is the dependent variable. The next part of this question is asking us to make a table showing the number of pencils purchased for 3 through 7 packages. That means that we need to start entering in our package numbers here on the left-hand column. As you can see, the number of packages change, and that will affect the dependent variable, or the number of pencils that are purchased. Now let's look at the equation that Sarah came up with to determine how many pencils there are total when there is a certain number of packages purchased. In order to do that, we need to take this equation and start to plug in our own numbers. Once we do that, we can easily solve. 12 times 3 is the same as saying 10 times 3 plus 2 times 3. So 10 times 3 is 30, 2 times 3 is 6, so we get n equals 36. So there are 36 pencils when p is equal to 3, or when there are 3 packages of pencils. Now, because this is a rather simplistic equation, it's really just 12 times p is equal to n, you can see, just like in our example from the previous video, that if we go on to the next one, we're just adding one more package of pencils to this. We're going from 3 to 4 and just adding one more package of pencils. So we are literally counting, or skip counting, by 12, starting with 36. And if you started from one package, we already know 1p is equal to 12. So then 2p would be equal to 24, and then 3p would be equal to 36. That's what we solved down here. So if we continued with that pattern and we went 4p is equal to 48. We're just adding another 12. Okay, so you could skip count and you could end up with the same exact answer. But let's say we don't want to skip count and we want to solve from the formula, and let's go ahead and skip to the 7th package. If n equals 12p, then we can plug in 4p. N equals 12 times 7. 12 times 7 is the same as saying 7 times 10, which is equal to 70, plus 7 times 2, which is equal to 14. 70 plus 14 is going to give us 84. N will be equal to 84, and therefore, with 7 packages of pencils, the number of pencils will be 84. Now let's check to see if skip counting actually did work. We started with one package. One package of pencils was equal to 12 total pencils. We skip counted by 12, and we went from 12, 2 packages, to 24, 24 to 36, 36 to 48. And we add 12 onto 48, we shall get 60. And then when we go and add 12 to 60, we should get 72. And then what happens if we add 12 to 72? Well, if we add 12 to 72, we get 84. So it works out by skip counting, and it also works out by substituting P for the number of packages that there are. Just remember, all we did was look at the equation that was already created, and then we substituted in the independent variable for the number of packages to solve for n, our dependent variable. Just to be clear and reiterate here, the dependent variable n is going to change depending upon the independent variable's value. As you can see, the independent variable changes and the dependent variable changes as a direct result. 3 packages gives n equal to 36. 4 packages gives n equal to 48. Remember that as we move on to our next exercise. Go ahead and read this along with me. Charlotte reads 4 books each week. Let B be the number of books she reads each week, and let W be the number of weeks that she reads. Determine which variable is dependent and which is independent. Then write an equation to model the situation, and make a table that shows the number of books read in under 6 weeks. Pause. Now it's your turn to go through and read what we just read. Go ahead and read it another 2 times, and make sure to circle, highlight, underline, or square important information you're going to need to solve the rest of this problem. Now that you've taken some time to try this on your own, let's go ahead and take a look at the things that I highlighted and underlined on exercise number 2. Now, there's something a little bit confusing about what they say here, and it's when they look at let B be the number of books she reads each week. Well, B is not actually going to be equal to the number of books that she reads each week, because Charlotte reads 4 books each week. So B is actually going to be equal to the total number of books she's read, not necessarily the amount that she's read each week, because each week it says that the rate is 4 books each week, and that can be expressed by 1 to 4. 1 week, 4 books. And that's a good little ratio right there. We can even say it's a W to B ratio of, for every 1 week that goes by, she'll read 4 books. The rate is 1 for every 1 week 4 books are read. That means that B does not equal the number of books she reads each week, but it's equal to the total number of books that she reads, given the amount of weeks that she reads. W is the number of weeks that she reads. The number of books she reads each week is equal to 4. So this question in itself is kind of confusing. We need to determine which variable is dependent and which is independent. In this case, we have a week. The weeks are going to change because we actually want to go all the way up to 6 weeks. So we're going to have 1, 2, 3, 4, 5 weeks within these columns. So the weeks will change. That also means that the total amount of books read will change. But the total amount of books read is determined on how many weeks we are reading the books. The total number of books read, or B, is dependent upon how many weeks we spend reading books, or Charlotte spends reading books. So the weeks, or W, is going to be the independent variable. It will change and it will affect the variable B, which is the dependent variable. The total number depends on how many weeks we're reading. Our independent variable is the number of weeks, or W, and our dependent variable is the total number of books read, or B. So we went ahead and we labeled the table. On one side, the very first column is labeled number of weeks, or W, our independent variable. And the second column to our right is total number of books, B, which is our dependent variable. We are not finished though. Unlike the last problem that we worked with just above, we had an equation already that Sarah came up with. And in the previous example, we had Marcus who came up with the equation. Now we have to write an equation to model the situation. Since B is the dependent variable, it is reliant upon the input of W. When W's input changes, or we substitute a different value for W, B is going to change as a result. That means our equation is going to be B is equal to 4 times W, or the amount of weeks that was read. So now if we fill in our weeks over here, we can plug or substitute for W in our equation over here. They're looking for us to solve for a total of 6 weeks, so let's make sure that we have 1, 2, 3, 4, 5 in under 6 weeks, so less than 6 weeks. So we're just going to be doing 1, 2, 3, 4, 5 weeks. So let's go ahead and make sure that we've marked that in. Number of weeks, 1. Number of weeks, 2, 3, 4, 5. And now we have our 5 weeks. Now all we need to do is substitute these values in this column for the W in this equation, and we'll solve for B. So I went ahead and filled in 4 for 1 week because we already know that it is 1 week, 4 books read type scenario. When 1 week of time has passed, 4 books will be read. Well, for the next equation, though, B equals 4 times 2 because now 2 weeks, and B is equal to total number of books. So we will solve by solving 4 times 2 because we substituted 2 for W. 4 times 2 is, of course, 8, so B will equal 8. And again, you can see that there is a skip counting going on of 4s. So 4, 8, and as you can guess, the next one will probably be 12. Let's see by plugging in what we need to for the equation. So I'm just erasing so that we can plug in again. B is equal to 4 times 3. What's 4 times 3? 4 times 3 is 12. So we have 12, and it follows our skip counting. Let's go to the next one. Let's erase, though, so we have some room to work here. And you need to pause to copy these down. Go for it. I'm going very fast. So B equals 4 times 4. What is 4 times 4? 4 times 4 is 16. We added 4 to 12. We got 16. Let's try the next one. Maybe you can guess what this next one is going to be. You want to take a guess? Go ahead and write down your guess right now, and then let's solve. B equals 4 times 5. B equals 20. Again, if we added 4 onto that, it would be 20. We have not only developed the equation, okay, to solve, but we went and we solved for all aspects of the table. Now that we have finished exercises 1 and 2 together, it is your turn to go to your book and finish the rest of the exercises, which is 3 and 4. Then come back to the video, watch until the end of the video to find the answers to the exercises for 3 and 4. Check your answers against the answers on the video and see if you got yours right or wrong. Stop. Do not move on unless you have done exercises 3 and 4 on your own. Only move on if you are ready to check your answers. If you are ready to check your answers, you can continue to play this movie. Here are the answers to exercises 3 and 4. The The answers are in blue here. You needed to complete the table just like they have here. Please check your answers on this video. Pause if necessary. If you got anything wrong, please pause and take a look and figure out why you got it wrong. Look back at our lesson video and also look back at the 2 exercises that we did together.